find the turning points of a polynomial, the maxes and mins, we're going to need to use a graphing calculator to do that. So I've gone ahead and already typed my polynomial in, and while you're typing in just a couple things you may want to pay attention to. So since this is degree 3, as we talked about in class, I know this polynomial will have at most 2 turning points. There's always, or at most, 1 less turning point than the degree. So if I take a look at what my graph looks like, I mean, I sketched it there, but here's what the graph actually looks like. I can see that, yeah, it does have 2 turning points. It has a maximum, we'll call that a local maximum, and it has a minimum, a local minimum. So let's go ahead and find those actual coordinates. So it's the same thing we did with parabolas a while ago, if you remember that. So max and min is located under the calculate menu, so select second, trace, and doesn't matter which one you find first, let's find the maximum first, I suppose. So select maximum, make sure you do pick the right one, don't select minimum if you're trying to find maximum. So select maximum, they're gonna ask you those 3 questions, left bound, right bound, and guess. So this is not where you can just go close to it and press enter 3 times. Instead, take your cursor, move it to the left of that maximum point, so that's fine, press enter. You'll see an arrow or this line pop up. Then they'll ask you to go to the right of it, so move over here to the right of that maximum value somewhere, that should be good. Press enter and guess, just press enter a 3rd time. And there we go, it'll calculate the maximum value. Now most of these are going to be really, really nasty decimals, so let's agree to just round to 2 decimal places, so I've done that here. To find your minimum, same thing, just select minimum. So second, trace, this time select the minimum value. And once again, they'll ask you the same 3 questions. They'll say go to the left of the 0, go to the right of the 0, and press enter. So left of it's over here, right of it's somewhere on this side, and then for guess, just press enter. And once again, your decimals are usually going to be really nasty for most of these, so let's just agree to round to 2 decimal places. So there's my maxes and mins. Now keep in mind, you may have more than one max or min. If your graph is one of those W graphs we've looked at, there may be 2 minimums, and you do need to find both. It's not just find the minimum of the minimums, it's find all the low points and all the high points. This one only had 2 though, so we are done. Now that we've found the local max and local min of this polynomial, let's go ahead and describe the intervals where the polynomial is both increasing and decreasing. These are going to use our local max and local min. So I made a really rough sketch of what we just found in order to help us answer this question. What I want to imagine is this is a roller coaster and I'm riding it from left to right. So as I begin riding that roller coaster, I can see that I'm increasing up until I get to that maximum value where I'll go down that first drop of the roller coaster. And so my first interval is increasing because it's rising. And so to describe this interval, I'm going to say I'm going from negative infinity all the way up to the x value. Increasing, decreasing intervals always only use the x values. So I'm only looking at these. I don't care about the y values for intervals. So I'm increasing up until I get to this point, or this x value of negative 1.87. Okay. After that, I start to drop, but let's look for any other spots where we're increasing while we're talking about increasing. So I'll go down the hill, that's fun. And then I get down to the low point where once again, I start increasing again. So there's a second interval where this graph is increasing. I'm going to use that union symbol to say that there's a second spot where I'm increasing. And once again, I'm only using x values. So the x value over here at this wall was 0.57. And then the graph will continue increasing forever as x goes on to infinity. Well, let's talk about that decreasing interval then, the fun part of the roller coaster where we're dropping down. So there was one interval where we were decreasing. And once again, I'm going to label this only with the x value. So I'm decreasing on this part of the roller coaster just down there. So between those 2 walls that I drew, the 2 x values, the first one occurred at negative 1.87. And I was decreasing all the way until I got to that second x value, that second wall at negative 0.54. So there's my description of the intervals where this graph is increasing and decreasing. Notice I also only use parentheses. I never use the square brackets in increasing, decreasing intervals. I only use the parentheses and only use the x values.